Hey y'all, I wanted to talk a little bit about species. Let's talk about bats. So some of the species you got here are represented by points. So like eagles, right? Eagles is an example, right? These are eagle points of some sort. Now, one of the questions I got is how do I figure out what these things mean? And yeah, it takes you got to do some investigation, right? So I'm cracking open the table here. Okay, so area not meaningful to a point, perimeter not meaningful to point. Eagle F and Eagle F ID, these look like unique IDs. Num, it's all 99999. Let's see, a descending, ascending. There's those numbers mean something, but I'm sure not sure what they mean, so I can't really interpret it. Type, well, type is usually distance is 0, polygon ID, scale, angle. That looks like, I don't know, cartographic stuff. But type usually means something. So let's go ahead and symbolize by type. Okay. Oop. Symbolize and add all the values. Okay. P and R. Okay. I would really like some sort of context here. Let's drop the lakes layer in here. You know what? That's let's see anything distinct in there. Lake Lake 98 or 99. Okay, so properties, category, lake, add all values. Okay, so 98's water, so I'll make that lake, and 99 is land, so I make that beige. Okay, now we're getting somewhere. Okay, let's see. Eagles, lakes. What might P and R stand for? What do eagles do? Um, hmm. Well, they perch and they roost. So these are probably, I'm gonna make them just a big. These are probably roosts. Um, and then these ones are probably perches that they hunt off of. So that gives me a sense of what they might be using. That's kind of interesting. They've a lot of perch notices there. This is kind of a dry lake though, so that does make some sense. And this is the shallow end of the lake. Certainly, these points seem to conform with the boundary. So I don't know. Maybe could my data be off? Let's explore. Properties of Eagle. XY coordinate system. NAD 27 and lakes properties also says NAD 27 and I'm currently displaying NAD 27, so yeah, I'm guessing that's correct. Interesting, well, I guess we don't have anything for the south, so we don't know what on this where they perch on the south side. Yeah, and this follows the south side of the lake there. So yeah, so that's a little bit of discovery on eagles. Um, let's take a look at bats. Um, you know what? I'm going to zoom to the study area here. So this bats data here. The data format's a little bit different. It's coverages. They look like folders. They contain two things, like points and ticks. Ticks are just reference things from back in the day when we digitized on a plotter, a physical plotter. You actually tape the map up against it. Um, so there's different kinds of bat layers in here, but I want to understand what they mean. Now, there's a little thing in here called notes. Let's take a look at that. So okay, so I've got some information here. There's some evidence. It's got a distance, unknown, no evidence, no good, outside, and then these other two terms, mitos and Pluto. Um, and there's some more notes down here. So areas that have sightings of specific species are designated more important than those that have only evidence of bad activity. Areas of unknown are given a numeric value of 4 because potentially it could be a bad habitat. Areas that have no evidence and are not good for bat habitat are given a numeric value of 2 and show a slight possibility. Each data type should be separate at evidence and evidence, mitos, Pluto, no good, and unknown of both 92 and 93 coverages. So yeah, I think we got a sense of what those are. Let's see, edge. So just out of curiosity, uh, PLTO. Species profile from Bat Conservation International. So P Town is probably a P Townsend. It's some sort of Townsend bat. So these are what we've got is a couple specific species of bat. Myotis california is probably that other one. Mitos. Oh, he's not. I guess beauty's in the eye of the beholder. California myotis. Um, so yeah, so we've got specific kinds of bats. Um, let's explore the data a little bit. So, right, we've got evidence of bats. We got the myotis guys. We got the caves with no evidence. We've got caves that are no good for bats, at least at this point. The PLTO bats, and then some caves where they didn't know if they were good. We also have these other two layers here, 92 and 93. I assume these refer to survey years. So I'm worried that, I guess, I don't know, maybe these top ones contain these ones. So let's do some investigation here. I'm gonna make it a big fat circle and mark it as yellow. And I put it under the other points so we could take a look at it. So it looks like um, most, but not all, the caves. It looks like all the caves in 92 are in one of these other layers. Let's look at 93. Drop that in there. Alright, we'll make this one red. Alright. Yeah, I'm not seeing any red circles where we don't have one of the other ones. So yeah, it looks like all the 90, 92, and 93 surveys are in these subdivisions, so we can ignore those. So these are the bats that I'm interested in, and these are calculate distance. So these list bat 93 buff. So these are actually probably the buffer distances. So where I have the endangered bats, they get a 150-meter buffer. Where there's evidence of bats, they get 100. If it's unknown, it gets 75. If there's no evidence, it gets 50. And if it's no good, we ignore it completely. Um, And then outside the bat area is 1. This here probably should be 1 as well. So that's kind of how you do investigation on some of the point species. Let's just briefly look at like deer use. This is a good example. Another good example. Um, right? If I zoom to it, the whole area is green. Does that mean the whole area is deer usable? Um, well, no. If I open up and look in the table, there's a field there called use types. So let's go to properties and use types, add all values. Right, so now I know, yeah, the purple area is none. It's not really a primary deer use. This blue area is key winter use areas. The brown area is just key use, and the green is winter use areas, but less important, right? So that gives me kind of a priority. So yeah, I mean, some of these are going to be easier to interpret than others, like going off of species geology. Again, let's look at the table. There's a value here called geology. Um, right. But yeah, I don't know what those numbers mean. Uh, have to go in and see. Yeah, there is a geology. Okay, so yeah, there is. There we do have a text file in here that tells us the different kinds of rocks. And so maybe you could learn about those rocks and understand which ones are more seismically sensitive. Yeah, but we do have a big old data gap on the north side for geology. There's no geology out here in the north, so you'd only be able to use geology to make decisions inside this boundary. So, um, OHV, off-highway vehicles. This is another good example. So we got a bunch of boundaries and a bunch of points. So if we look at a point, OAR closed to all. So okay, so these points indicate what the polygons are. Well, these aren't even polygons, these are lines. So you'd actually have to create polygons out of these lines. Um, so create polygon. Okay, so I did a search for create polygon. There's decent polygons, but we don't want to do those even, so those kind of triangular polygons between these points, we actually want to fill real polygons. So if we get featured polygon, right? Yeah, I could probably use this tool, right? Use these lines to create some polygons and then spatial join the values from the points to create some usable off-highway vehicle data, recreation data on off-road vehicles. So yeah, I'm just trying to give you a sense of what the exploratory process for looking at some of this is. So I just added in tests. So what does tests mean? Tests. Let's see, tests, conservation. Form of energy. Tests, species. Endangered species. Okay, test programs include management done for threatened, endangered, and sensitive designated. Okay, so it's a species designation test program. Okay, so that gives me a little bit of a background. Let's look at inside. There's a again kind of normal stuff, but there's something called test habitat, test hab. So let's explore it. Test hab, add all values, right? So okay, you know what? I'm gonna drop that lake in here again as a reference. Okay, yeah. So there's all kinds of different habitats in here. Meadows and sage flats and wet meadows and pea plain. Let's see. Pea plain, Big Bear. Let's see. Habitat. Pebble plain. Okay, in San Bernardino Mountains, the grass occurs in pebble plain habitat. Pebble plain. Pebble plain. Okay. Well, let's see. Pebble plain habitat. Right. Pebble plain. Only in Big Bear. KBHR. Okay, so this is a unique habitat type to the Big Bear region, right? So this, again, I'm doing my bit by bit discovery of what some of these mean as data types. So that's kind of how I would approach it. So.